In this video, we're going to look at some more definitions of functions based on their graphs. These definitions look like a nightmare, but they're really not bad at all. A function f is said to be increasing on an open interval. Open interval, guys. It's defined that way, so don't ask me if you need to include that value or not. The answer is no. It is an open interval. If the y values are increasing whenever the x values are increasing. A function is said to be decreasing on an open interval if the y values are decreasing while the x values are increasing. And a function is said to be constant on an open interval if the y values remain the same as the x values change. Let's take a look at an example to make certain that we understand what we're talking about. State the intervals on which the given function is increasing, decreasing, or constant. Okay, increasing means the y values are increasing. That means I'm going up as I move from left to right. Left to right is how the x values increase. So going up from left to right, if I'm moving left to right, I'm coming up on this whole part of the graph until I get right here. Okay, until I get to -1. So from negative infinity up to -1, I am in the increase. At -1, though, I start moving downhill until I hit +1. So from -1 to +1, I am decreasing because the graph is going downhill. But then it turns and goes uphill again. So from 1, and it hits the arrow this time, so to infinity, and I stick a union between them because you can't be in both places at the same time. And there is no values, no interval on which that graph is constant. Again, we're going to take a look at the absolute value function now, just to do the same, make sure we've got our definition down good. Increasing is when it's moving up from left to right. Decreasing is when it is going down from left to right. And constant is like a horizontal line. Okay? So if I get all the way to the left of this, I am moving downhill. So that is a decreasing function until I hit 0. So from the arrow on the left, which represents -infinity, up to 0, I'm moving downhill. But at 0 and all the way to the arrow on the right, I'm moving uphill. And there is no interval over which the graph remains constant. Okay, another concept that's not totally new to you, but I want to stress a few things. A function value is a relative minimum. This is not a point. It is defined to be a value. So when I ask for the relative maximum, I'm not looking for a point. I want just the value. That means give me the y value, no x value. Okay? So a function value is a relative max of f if there exists an open interval containing a such that f of a is greater than f of x for all x not equal to a in the open interval. In other words, something's going on in this graph. It may go down, and it may even go up forever. But this point right here at the top of that hump, that is a relative maximum. All I've got to do is cut off my graph here, cut it off here, box it in and say I want the maximum of this area. It is a max. It is a relative max. It is not an absolute max because this graph wouldn't have one with the arrow going up forever. So that's the difference between the absolute maximum that you've looked at before and the relative max. The relative max is just a max on some small interval. It does not have to be the max of the entire function. Same story about the relative minimum. Okay, it can go down forever, it doesn't matter. If I box in right here and say, let's just look at this interval of x's, I do have a minimum value. And that minimum value will be my relative min. So again, let's take a look at an example where Miss Harrell has marked them for me. Identify the relative max and the relative min. Notice they're not giving me an interval, because the whole point is that this interval gets smaller and smaller. But if I were to break up this graph, let's say right here, I have a relative max. It seems to be, I don't know, between 2.5 and 3. That's what I don't like about graphs, and you'll see we'll do the algebra to find it eventually. And I have a relative min right here in blue that also looks to be -3. So I have a relative max of +3, a relative min of -3. One last example with our sine wave again. Identify the relative max and min. Well, notice I have a relative max sitting right here, and it will occur infinitely many times, but it always just hits the 1. So the relative max is 1. The relative min, by the way, you see how that's plural? Okay, you don't hear it when we shorten it to max and min. The relative min down here is going to be -1. And it will occur infinitely many times.